Hello everyone and welcome back to Easy X Math. So I hope you're all doing well and you're keeping up with the work. Really, I'm really proud of you guys, especially those who have been updating me about their grades and how they're doing in math classes. I'm extremely proud of you guys and keep up the good work. So today I decided to do a video on rational exponents, specifically some practice questions to expose you guys to some of the questions that may come either in testing as far as ACT, SAT, and even in your regular classes. So here it says, so I will have two parts, part 1 and then part 2. Part 2 will be dealing with polynomials, how to multiply or divide polynomials with rational exponents. But today I'm just looking at how to use the properties of exponents to simplify different expressions. So here we have, let's look at the first problem. Okay, the instruction says use the properties of exponents to simplify each of the following expressions as much as possible. Assume all bases are positive. Okay, so look at the first one. They gave me x to the power of 2 over 7 divided by x to the power of 5 over 7. So looking at that, I'm looking, what property should I use? Okay, so I'm thinking of division. So they have the same a to the power of m over a to the power of n. So same base, division, keep the base and subtract the exponent, so m minus n. So that's the property that I will use that. Okay, so now we get x to the power of 2 over 7 minus minus 5 over 7. Right, so that is x. Okay, subtracting two fractions, they already have the same denominator, so I keep the denominator and subtract the numerator. 2 minus 5, that's negative 3. All right, so that's my answer for the first one. Okay, so first you identify which property you will be using and then you apply it. There are cases where they would like you to leave the answer with the positive exponents, right? So if you haven't done so, please make sure that you watch all the videos on exponents before you get to this part. Okay, so I said that you can rewrite negative exponents using a fraction with the positive exponents. Okay, so this is the same as x 1 over x to the power of 3 over 7, right? So rewriting using fractions. So that was pretty much for the first problem. The second problem says y to the power of 4 over 9 times y to the power of 7 over 9. Okay, so here I'm multiplying exponents. So I see that they have the same base, right? It's the same base under multiplication. A to the power of m times a to the power of n. That's the same as a to the power of m plus n. Okay, so I keep the base and add the exponents. So I keep y and add the exponents. So 4 over 9 plus 7 over 9. All right, so adding fractions, they already have the same denominator. I keep the denominator and then I add the numerators. So 4 plus 7, that's 11. And I'm pretty much done. Right, so you need to remember the formulas and you need to remember the properties. Okay, so far we did same base multiplication, same base division. Problem 3, I'm given, right, x to the power of 3/5 times y to the power of 5/6 times z to the power of 1/3, all to the power of 3/5. Okay, all right, so here I can see that I have different bases, right? So I have x, y, and z, right, for one exponent, right? So then I will use the formula where you have one exponent for at least two bases. You distribute the exponents to the other exponents, right? So I will distribute these exponents to the other exponents. Okay, so then what do I end up having? Well, I will have x to the power of 3 over 5 times 3 over 5. Remember that you're distributing the exponents to the other exponents, not to the bases. Times y to the power of 5/6 times 3/5 times z to the power of 1/3 times 3/5. All right, so this gives me, okay, 3 multiplying fractions. You multiply straight, right? So you multiply the numerators together and the denominators together. So 3 times 3, that's 9, and 5 times 5, that's 25. That's for x. And then for y, I have 5 times 3, that's 15, over 6 times 5, that's 30. Okay, and then z to the power, so 1 times 3, that's 3, and 3 times 5, that's 15. Okay. So here, looking at the exponents, there are some that I can simplify. Okay, for here, 15 over 30 can be simplified, and 3 over 15 can be simplified, right? So the answer now leaves me to 9, x to the power of 9 over 25 times y to the power of 15 over 30 can be simplified as 1/2, and then 3 over 15 can be simplified to 1 over 5. So that's pretty much. So here we saw that we used multiple bases for one exponent. You take that exponent and you distribute to the other exponents. All right, problem 4. So I'm given a to the power of 3/4 times b squared over a to the power of 7 over 8 times b to the power of 1/4. Okay, so here I will look at them individually. Okay, so I see that I have a and a, right? So same base, right? So let me look at this part first. So same base under division, so you keep the base. Okay, so I will keep the base and then subtract the exponents. So that would be 3/4 minus 7/8. Okay, and then the other part b, right? Again, same base. Under division, keep the base and subtract the exponent. So that would be 2 minus 1/4. All right, but now some of you guys are wondering, okay, so what should I have in the middle here? Is it multiplication? Is it division? What is it? It's multiplication. Why? Because you broke the fractions. You broke it into 2 fractions, right? So when I give you, for example, 2 times 3 over 5 times 4, right? You can break it out into 2 over 5 times 3 over 4. That's the same thing that we did here, right? So you see that here you will have multiplication, not division. All right, so we subtracting fractions, they don't have the same denominator. So we have to find a common denominator. So times 2 times 2. Since the greatest common factor here is 8. Okay, so I will end up having 6 over 8 minus 7 over 8 times b. Okay, so see, this is 2 over 1 times 4 times 4. So 4 times 2, that's 8, and 4 times 1, that's 4, minus 1 over 4. All right, so now they have the same denominator. Okay, so a. So I keep the denominator and subtract the numerators. So 6 minus 7, that's -1. And here I have b to the power of, keep the denominator. So 8 minus 1, that's 7. So your answer at the end is a to the power of -1/8 times b to the power of 7 over 4. Okay, all right. So we're not multiplying. Okay, let me erase this. We're not multiplying the exponents. All right, so does that make sense? Okay, so let's say instead they wanted to have, right, to have the answers as positive exponents, right? So now I have to change this into a positive exponent. Well, that's pretty easy, right? So you know that you will have, you write as a fraction, 1 over a to the power of 1/8, right, times b to the power of 7/4. If you see, I kept the b to the power of 7/4 on the top. I didn't write it as a fraction. Why? Because the exponent is already positive, right? And this is multiplying fractions. You can have one on the bottom, right? And when you're multiplying fraction, you multiply straight. So 1 times b to the power of 7/4, anything times 1 is itself, so b to the power of 7/4 over, okay, a to the power of 1/8 times 1, that's a to the power of 1/8. So here is your answer. All right, pretty interesting. Okay, so I have y to the power of 2/3 all to the power of 3/4 over y to the power of 1/3 to the power of 3/5. Okay, so here I have, if you look at the numerator, okay, I have one base for two exponents. So what do? We keep, so a to the power of m all the way to the power of n is the same as a to the power of m times n. So basically we multiply the exponents. So for the numerator, I will get y to the power of 2/3 times 3/4. Okay, and then for the denominator, I will get, okay, I will have the same thing as well. So one base for two exponents, keep the base and multiply the exponents. So 1/3 times 3/5. Okay, all right. So then on the numerator, I get, so 2 times 3, that's 6, and 3 times 4, that's 12. And the denominator, excuse me, I have 1 times 3, that's 3, and 3 times 5, that's 15. Okay, all right. So is there a way I can simplify 6 over 12? Yes, so that's the same as 1/2, since simplified by 6 by 6. Okay, and here I can simplify by 3 by 3. So that would be y to the power of 1/5. All right, are we done? No. So we have to keep on going. So here now I see that I have same base under division. So, well, you keep the base, right? I will keep the base. My base here is y, and then subtract the exponent. So that's 1/2 minus 1/5. Okay, do they have the same denominator? No. So find the least common multiple, times 2 here, and times 5 times 5. So this would be 5 over 10 minus 2 over 10. So that's the same as y to the power of 3 over 10. So here you see that we used two principles. We used two concepts. So first, when you have one base for two exponents, and the second one was when you're dividing exponents with the same base. All right, so problem 6. So here I have a to the power of negative 1/4 over a to the power of 1/2 all to the power of 8. So it's the entire thing that is to the power of 8, not only the numerator, but both the numerator and the denominator. All right, so what do? So if you remember what we said, that when you have one exponent for two bases, here you have two terms in the base, right? So we said that we distribute the exponents to the other exponents, okay? So on the numerator, I will distribute it. So that's the same as, or for those who want to see it this way, so I will have negative a to the power of negative 1/4 all to the power of 8, okay, over a to the power of 1/2 all to the power of 8. Okay, now the numerator, what do I have? One base for two exponents, so I keep the base and multiply the exponent, so that's negative 1/4 times 8. And then on the denominator, I have a to the power of 1/2 times 8. Okay, so here negative 1/4 times 8, that's negative 8 over 4. And then the denominator, I have 1/2 times 8, that's 8 over 2. All right, so then for the numerator, I have a to the power of, so 8 divided by 4, that's 2, a to the power of negative 2, and then 8 divided by 2, that's 4. All right, so now here they have the same base, right? Under division, we keep the base and we subtract the exponent, so that would be negative 2 minus 4. All right, so negative 2 minus 4, same sign, keep and add. So we keep the negative sign and we add 2 plus 4, that's 6. So the answer is a to the power of negative 6. If we're looking to have the answer with positive exponents, well, you change it as a fraction. So that would be 1 over a to the power of 6. Problem 7. All right. So we look at it differently. Okay, but still the same concepts. So for the numerator, right, so I see that I have two bases here. I have r and s, right, for one exponent. So I will work with the numerator first. Okay, so then I will distribute the exponents to the other exponents, as we know, right? So that will be r to the power of negative 2 times 6, and then s to the power of 1/3 times 6, right? And the denominator, I only have two bases, right? Each one of them has their own exponent. So then I will keep it as r to the power of 8, and then s to the power of 3/2. All right, so then negative 2 times 6, that's negative 12, and then s to the power of 1/3 of 6, that's 2. All right, over r to the power of 8, and then s to the power of 3/2. Okay, so here you see we have the same base, r and r. So I will take them individually. I will take this part first. So r to the power of negative 12 divided by r to the power of 8. All right, so same base under division. You keep the base and you subtract the exponent. So negative 12 minus 8 times, okay, look at this part now. So s to the power of 2 minus 3/2. Okay, so now subtracting r to the power of negative 20, same sign, keep and add. And here I have s, they don't have the same denominator, so times 2 here over 1 times 2. So that's 4 over 2, excuse me, minus 3 over 2. All right, so that's r to the power of negative 20 times s to the power of 4 minus 3, that's 1/2. Okay, so if you were to write it with positive exponents, again, I just want to add that part. So I will turn the negative exponent into positive exponent. So that would be 1 over r to the power of 20 times s to the power of 1/2. Okay, so I will have over 1 multiplying fractions, right? We multiply is straight, so the numerators together and the denominators together. So 1 times s to the power of 1/2 is s to the power of 1/2, and then r to the power of 20 times 1, that's r to the power of 20. So let's look at the numerator first. Okay, so here we can see that again I have two bases for one exponent. Actually I have 3, because I have a number this time, right? I have 25. Okay, so I will distribute. So 25 is the same as 25 to the power of 1. For those who feel that that still doesn't make sense, I will just have 25 to the power of 1 here. Okay, now every single base, so the first base is 25, the second base is a, and the third base is b here for the numerator. So 25 to the power, 25 is the same as 25 to the power of 1. All right, so all of them have exponents now. So we have 3 bases for one exponent. We distribute the exponents 1/2 to the other exponents, okay? All right, so what do we get? So I will get 25 to the power of 1 times 1/2 times a to the power of 6 times 1/2 times b to the power of 4 times 1/2. All right, so we'll do the same for the denominator. Okay, so 8, since it's only 8, I will have 8 to the power of 1 and then distribute. So that will be 8 to the power of 1 times 1/3 times a to the power of negative 9 times 1/3 times b to the power of 3 times 1/3. All right, so 25, so 1 times 1/2, that's 1/2, so that's 25 to the power of 1/2, and we know that 25 to the power of 1/2 is square root of 25 to the power of 1/2, same as square root of 25, and square root of 25, that's 5. So if you haven't done so, make sure that you watch all the videos about exponents, and it will make sense. So I have 5 here. All right, so 6 times 1/2, so half of 6, that's 3. Okay, and then half of 4, that's 2. Okay, and then 8 to the power of 1 times 1/3, that's 1/3. 8 to the power of 1/3, that's 2. Okay, a to the power of, so negative 9 times 1/3, so 1/3 of negative 9, that's negative 3. And b, 1/3 of 3, that's 1. B to the power of 1. All right, so here I have 5/2. Okay, I will break it down. 5/2, it's just going to be a number. I will keep it. You don't have to turn it into a decimal. You can keep it as a fraction. Okay, so a now, so same base, under division, you keep the base and subtract the exponents. That's a to the power of 3 minus, so the top exponent minus the bottom exponent. The bottom exponent is already negative. So I have negative 3. So it's not going to be 3 minus 3. It's going to be 3 minus, and this also already has a negative sign, I mean. So 3 minus negative 3, and then for b, I have b to the power of 2 minus 1. Okay, so that's 5/2. Okay, times a, so 2 negative signs following each other will turn into positive. So 3 plus 3, that's 6, and b to the power of 2 minus 1, that's 1. Luckily here, all the exponents are positive, so you don't need to change anything. So that's your answer. All right, so some may have found, okay, 5 times a to the power of 6, b over 2. So that's also the same, right? Because you also have here a to the power of 6 over 1 and over 1. And when you multiply in fractions, you multiply the numerators together and the denominators together. So those two answers are the same. Those two are the same. So do not get confused about this. All right. So this brings us to the end of this video. Again, we look at a couple questions. So I think that once you master these concepts, the way you solve these questions, so any questions that you will be given with the same concepts, you will be able to do it with ease. Thank you for watching us. We'll see you next time.